Okay, all right, so recording. Okay, so we have, so again, a function takes an input, gives some type of an output. Generally, it's a bunch of, if statements, for loops, a bunch of like, logic that you have that you're wanting to wrap up inside of a, it's like underneath a variable name, essentially. Like you can kind of think of it as like a variable name for like a block of code that you can run. And so, so like qubit right here. So I'm going to break this out so it's not all on one line, but we'll say the const, I guess volume would be, if we wanted to call it that. I'm sorry, let's do a different, well, yeah, okay, let's just stick with this. All right, so volume will be equal to x times x times x. All right, so we have a cube, we're gonna find the volume. Here we go, find volume of cube. There we go, that's a more descriptive name. So, all right, so we have function, find volume of cube, and then we give it x, which is the length of, a size. We're assuming that it's a cube, so all the different sides are the same. So there's some basic geometry refresher. So, all right, so the volume is going to be x times x times x, and so that's going to give us the volume of the cube. And then now we're going to do return volume. So we receive input, we do some work, and then we return a value. Variables that we define and everything, they're all going to live inside of this function scope. The idea is that, back when programs were first being created, like they created like some basic logic, like if statements, for loops, things like that. And then what they realize is that when you have these big, long blocks of code, you reach a point where there's maybe tasks that you're repeating over and over again. So like, okay, like I have to write this single piece of code over and over and over again. So what you can do is you can then take and make a little function. You can put that into a function so you can just reuse it. You just have that one block of code that you can use everywhere you need to use it. You don't have to rewrite all of those like basic instructions every single time. A key thing with programming that'll make you a better programmer is you don't want to be repeating yourself. They call this the DRY principle, do not repeat yourself, DRY. And so the idea is that if you ever find yourself writing the same pieces of code over and over and over again to solve a similar solution, that's usually a point where you could break that out into its own function, separate out that functionality. So, all right, so right here we have this function, find volume of cube, and it's reusable. So we can reuse it for different dimensions. So let's say that we'll say const result is going to be equal to find volume of cube. I'll call this volume, might be a little better. So find volume of cube, and then I'm going to say 5. All right, so we say find volume of cube, it's a reference to this function. It's just, this function could be 1,000,000 lines of code long, or maybe it's just 2 lines of code long, or 1 line. None of that matters. It's just a block of code that's all kind of separated in its own little capsule. And then what we're doing is we're referencing that block of code. We pass in this number, this argument. We could pass in an infinite number of arguments. Well, not infinite. There is a limit on it. It's like 200 or something, but you're never going to reach that. Usually it's going to be like just a couple arguments that you'll be passing in. But so this input that you're passing in goes in one end, and then we're going to do some work, and then we're going to get an output out of the other end. I'm going to do a little diagram for you guys, actually. And often, like mastery of the language and of programming principles comes when you dive into the nitty-gritty of the basics. That's what's really going to help you guys just really master this stuff. And so it might seem kind of basic, some of this stuff, maybe it's not, but it helps to just, really dive in and thoroughly understand all of the corners of this. So, all right, so here's our function, and it's this box. The way that we want to be able to mentally think of this is it's like this black box where we don't know what's going on inside, and we don't care to know what's going on inside. We just know that if we give it an input like 5, then it is going to give us the volume. Like we don't need to know how the function is used. Like right now I'm writing it this way, but often you'll have like a library that'll have a bunch of pre-built functions. Like when we get into React, there will be functions that'll be made for creating your React components and stuff like that. And you don't have to know how the function is written. You don't care about that. You just know if I give this an input, then it's going to give me this output. And if I call this function right here 1,000 times with a 5 coming in, it's always going to give me the same output. So that's the idea behind a function. It's this reusable block, and you give it an input and it gives an output. And then you can use this block in a combination with other blocks, and your application is built using these functions. So again, you have the input that comes in, which right here is the x. The output is everything that we return. There can only be one output out of a function. You can have lots of inputs coming in, lots of arguments that would come in, but your outputs can only be, it's only one thing. So when you hit return, the function stops. If you put any code behind it, so if I did like volume is, so if I did that, this would not work. Like this, or this console.log would never, you would never reach it. So as soon as you hit return, the function's over and it's done. It's not doing anything else. So those are kind of the key aspects of a function here. So again, a function has its own scope. So we cannot reference, so right here, we have these two different volume variables. And so, well, actually it might, because I'm redefining it in this. Well, no, that should be fine. Man, JSBin is being a pain. It's just like the last like 2 or 3 days I just started doing this. It's worked for me for like 3 months with the other classes. So I don't know what's going on. Okay, but, oh, it's because I'm not logging the volume. All right, I assumed it was a bug with the software, and it's a bug with me. There we go. All right, so the volume prints out. So you can see here, we have 2 different volume variables that we're declaring. And so, and this is fine in this instance because this volume is inside of this function scope. Your variables should be unique to the function that they're in. So the variables should be unique to the function that they're in. Right here, I'm giving it the same name, but that's fine because it's inside of this containing function. There's times where maybe you wouldn't want to, or maybe you're reading stuff from outside functions like so. But just generally, this is okay right here because all the variables, every value, and everything that's living inside of this function, it's in its own little ecosystem. Okay, it's the same here. So again, general idea, you receive input, you return output. If you don't return anything from the function, then it by default returns undefined. Okay, so right here, and so again, another thing too that I'm going to be emphasizing with you guys is understanding the execution and the rules behind program execution and how your application is going to run. And so in this program, when I click this run button, what's happening is it starts right here, it sees the function keyword, and it creates a function foo in memory. And it comes down and it says, okay, function find volume of cube, and it creates a function find volume of cube in memory. Then it comes down here and it says, okay, const volume, so create a variable called volume. And then now assign the value of volume to whatever is on the right side of the equal sign. So then we come over here and it looks and it says, okay, find volume of cube. So it's going to go look and it's going to find what that is a reference to because it's like it's referencing a variable name. So it comes up and it says, okay, so find volume of cube is a function. And so then it's going to invoke it. That's what the parentheses mean. It's going to pass in 5. 5 is going to come here. So x will be 5. And then we're going to walk down line by line. So volume will be equal to 5 times 5 times 5. So volume, the variable volume is assigned then the value of 125. We come down, it sees a return statement. Okay, so it's going to return whatever is right here. And so that's, so it's the variable volume. It's going to come up, find the variable volume, see that it equals the number 125. And so then it returns 125. So this function then closes. And this right here, of this function name with the parentheses and the number, this is all going to simplify down to the number 125. The number 125 is assigned to the volume variable. We come down here, console.log volume. we log 125. Console is an object, log is a method. So we call the log method on the console object, pass in the number 125, and that is printed to the console. So that's everything that's going on here. That's how the computer reads it line by line from top to bottom. It's important for you guys to start thinking in those terms. You want to start thinking, how is the computer reading this? What is the flow of execution? That's going to help you to effectively debug problems in the future. Okay. So right here, what I'm doing is I'm assigning the result. So the result of calling the function to another variable. And so right now I'm being very, very explicit. If I were to condense everything down and write everything in a shorter way, then yeah, I could just actually wrap this directly inside of a console.log. So I could take this right here, and I could just stick that right there. And then this would still work. Also, too, you can comment out pieces of code, and that tells the program, it tells your computer to ignore the commented out lines of code. It's not run. So when you're like testing stuff, it helps to like comment out some code, and then it doesn't run. So a common thing to do, and most of your editors, you can do like Control/ or Command/, and then it will like comment out all of it. You can say, okay, so I want to comment out, this line of code real quick, and then like keep editing it. So it's a nice way for you to be able to go in and like change things. And okay. All right. So another thing. Okay. So this is functions 101. This is, we're just dealing with the very, very basics of functions here. So now I'm going to move into some of the more advanced concepts. So so I'm not reassigning the variable. So volume lives inside of this case, and then it exists out here. And so I'm actually not reassigning it, and that has to do with the function scope. So this right here is intentional. So you see like the variables they're living in two different places, two different environments. So so the linter might complain about it. It's like it might be better practice still like within a file to keep the names separate. But I'm just showing how the variables they do live within their specific scopes. Let's see, because this is being defined after here. So if I did constant volume up here and define it above it, then this might complain right here actually. But okay, so can I clarify regarding const and let? Let's see, I got a couple different comments. So put questions in Slack. Always put your questions in Slack. So let's try to get in the habit of doing that. Paste them in Slack. I have that open so I can read it. Because any questions that you type in here in Zoom are gone once the recording is finished, or like once the video call is finished. So all right, Ben, can I clarify regarding const and let? So no more using var, instead use const, the variable not be changed, or use let if there's a chance the variable will be changed in the future. Is that right? Nope, that's exactly right. And what I would say is just always use const. If you're not sure if something's going to change or not, use const. And then you'll see an error later when you run your code, and then you know you need to switch it to let. Always set things to const. Functions, arrays, and objects, you might have some questions about those. Those should be const. Even if you're going to modify the array after, like you're going to change the data in it, still use const because the actual reference isn't being changed. And so we'll get into like references of values in memory and stuff like that like later on. But yeah, just right now, use const for pretty much everything. Pretty much the only time you're using let right now is if you have like a number counter that you're going to be incrementing. So like in a for loop or like some of the closure problems, you do that. So pretty much that's, those are the only times you're going to use it right now. Okay, so there shouldn't be an array. So real quick, I'm going to delete this. I'll go post this in Slack real quick so you guys can see that. All right. Let me get rid of my annotations. Okay, so with arrays, so if we have const nums is equal to an array, we'll put 1, 2, 3, 4, 5. So here we have an array of numbers. So we can add things to it. So I can say nums.push 6, add something on the end. And now let's do const.log nums. Run that. We see 1, 2, 3, 4, 5, 6 is printed out. So it says you can still add to it. What's going to cause an error is if we tried to do nums is equal to 1, 2, 3. So if we try to make an assignment like that and run it, then we're going to see an error. So we can't make assignments to the variable. And so what it is you can't change the reference. You can't change the essentially what the rule is you cannot change. So a variable is a reference. A variable it's like a name, like a tag that points to a location in memory where there's some data. And so that the reference cannot be changed with a const. It cannot point to a different spot in memory. So this is maybe, so if this goes over your head, don't worry about it. I'm just going to talk about this for a second. This, this clarifies const and let the issue. So if you have a variable right here, I'm just representing them by little rectangles. You are assigning them to some data in memory. And so, so this right here would be a variable pointing to this. This variable is pointing to this other object in memory, so the thing in memory. And so with a const, if you try to change that reference and have it point to something else, then it's going to create an issue. So a const doesn't let you do that. So when you're doing nums is equal to an array and you do nums.push, what you're actually doing is you have this variable that points to this array in memory. The circle is an array in memory. And then what the push is doing is it's actually just like adding something else to the array. It's like modifying that object in memory, but the variable reference is not changing. And we're going to go into this in a lot of depth later on. So if this doesn't make sense to you right now, like don't worry, like we're going to go into this in a lot of detail later on. And how this works and variables and memory and all that stuff. Like you will totally understand this. But just for right now, a quick little intro. A variable is a reference to something else in like an object in memory. Memory is so really fast. Memory is like your short-term memory. If you restart the computer, the memory is wiped clean. The hard drive is like the permanent memory that persists between power cycles of your computer. So like memory is RAM. So like RAM, like your random access memory. And then like your hard drive is like, like either your platter or your SD, whatever. But it's a like permanent storage. So it persists between power cycles. So RAM is fast, and that's what your application is using. When your application is running, it's all of the data and everything's being stored in memory. We use databases and things like that to store stuff to the actual hard drive. And so again, we get into all of that later on in a lot of depth. But so this is all functioning within memory. So when your program runs, it's all spun up in memory, and it has to make use of this. It's like this space where things can be stored. Like temporarily, and then that's what your application is using. It's using this memory and this like temporary storage to like. It's like when you create a variable, like if you said like const name is equal to like your name, like so me like const name is equal to Ben, then the string Ben is like it's like pieces of memory are then allocated to hold that string, and then that can be changed and modified, and that's a whole rabbit hole that we can go down, but there's kind of a general introduction into it. But anyway, so that's the idea behind const and let. So let can be changed. And so like for example, when you have like a variable that's assigned to a number, so like if we had like if the number 1, if you changed it to a 2, it's not that it's actually like switching at the same spot, it's that it's like reassigning the reference. And so that does not work. But arrays and objects, you change the underlying object, and it actually doesn't change the reference. And so const is fine. Okay, so if that was too much, don't worry about it. All right. Okay, so back to functions. So again, function, it receives input, gives output. Okay, let's see a question popped up. Data that will be used multiple times, or is it acceptable to make variables out of data that is? So kind of depends. So like for example, in our like cube example, like for find volume. So some people could say that, you know, const volume is equal to x times x times x. So some people would say this is perhaps more like easier to read. And then some people would say that this is easier to read. We don't need to create a variable, just process it and you know what the function is doing. So kind of see like different thoughts on it. The more advanced you become, the more you'll lean towards this type of a solution. But then when you're learning, it can help you understand it and help you make more sense of it by using some other variables and stuff like that. So I wouldn't stress about this right now. I wouldn't worry about this. All right, so we talked about functions. Okay, so here's something that's interesting. So let's say we have const foo var. Actually, I'm going to change this name. I'm going to say call this say hi. I'm going to call this, well, I'll say log hi. That's very descriptive for what I'm saying. Log hi, log set. Okay, and then log hey. Okay, so 3 different functions that are all just logging, you know, like just printing something to the console. So I do log hi, log sup, hey, like that. We print it, hi sup hey. Okay, so this all print out. All right, so something interesting in JavaScript, JavaScript functions are first-class citizens. And what that means is that they can be put inside of arrays, they can put on objects. So right now I can say const functions is equal to an array. I say log hi, log sup, log hey, like that. There. And then now let's do log functions. And then you see like there's a bunch of like functions and stuff in there. So don't be confused by this. That's some stuff that JSPin is inserting in there, but it's an array of 3 functions. So you can fill up an array with functions, which is kind of an interesting thing. So we can do something like this now. We can say for let I get 0, I less than that. So we're going to iterate over functions, and then we're going to do functions at index I. So this right here allows us to reference a value in an array as we're iterating over it. This is super common, like a super common task, like iterating over an array from left to right and accessing the values one by one in turn. This is what you're going to be using to solve the each problem. So functions at index I. So this right here is going to evaluate to a function, and then we can invoke it. So the way that we invoke it is we put some parentheses on it, just like that. So notice right now I have nothing above here that's calling these functions anymore. But as we run it, we see hi, sup, and hey are all printed out. So again, the reason I'm writing it this way is so that way you can see that, so that you can see this idea of like how the code is evaluated. So right now we reference functions, and then we say at index I, so I will be 0 the first time the loop runs, and then this right here is going to evaluate to that actual function. So it's kind of like log hi is right here, and then we're going to use the open close parenthesis to call it. That's how we call a function. So a function has kind of like 2 states. It's like you have its like the actual function block, and then you can invoke it, and then you'll have the result. And so this right here it's like the actual function, and then we just call it with an open and close parenthesis. All right, so that's something we could do here too, as we could say like, no, this would need to be let, because we're going to be writing this, but I could say function at index, and then we can say, maybe that's a little easier to read. Maybe I should have started writing it like this. But this is just the same thing. And again, when I'm lecturing, when Ryan's lecturing, try not to follow along code-wise, like keeping up writing all the same code. Just watch, absorb, ask questions, and then, yeah, that's the way to do it. The problem is if you try to like follow along, it's easy to get lost and miss stuff. So, all right, so we look here, we have this for loop. So why did I use that? So I used let because each cycle of the loop, this variable is going to be overwritten. So I'm going to be overwriting function at index and assigning a new function from the functions array. So this would be an excellent piece of code for you guys to walk through. If you're having any questions about just the idea of like for loops and arrays and how all this stuff behaves, this would be some excellent code to just kind of like walk through step by step. So in fact, I think I'll walk through this again really quick. And again, you know, with any of the reviews that we do, if you know, feel free to like if you know if this is if anything I cover is ever too basic, you know, for most people it's not the case. But just, you know, if there's a couple of you in there that, you know, this may be too basic, you know, feel free to like keep working on stuff and then just like kind of half listen. But anyway, yeah. So that's not the case for 95% of the students, but just for anyone in there who, you know, you've covered a lot of this. So, is it common to use arrays containing functions? Yes, actually. I guess not like super common, but there are libraries and things that use that. It's not a, this is not some crazy esoteric like or this like weird little side thing that you're never going to run into. It's like this concept comes up. So it's important to understand this idea that of what a function is. I guess what I'm trying to get around is like what a function is and how it can be used. And yeah. All right, so let function at index is equal to functions at index I, then we call it. So, all right, so if our code is running, we're at the computer, we're gonna start on line 1. So we see, okay, log high. So then we do that, we come down here, come down to the log sep. Okay, we set aside a space in memory that's for log sep. We come down, find log hey. We create another block in memory, like another object in memory that's this function. And then we come down. All right, so now we get to functions. Okay, so create a variable called functions. It's a const, a left-hand like reference, and then it's set it equal to this array. Okay, so we have an array, so it's going to create a spot in memory for an array, and then it's going to go in and add some values into the array. So it's going to say, okay, at index 0, we want it to be whatever log high refers to. So log high is a variable. It's going to go up and it's going to say log high. All right, what do you refer to? It's this object, this function in memory. So that function is going to be there. And it's going to do the same thing with log sep. Go up, find it. What do you refer to? Oh, you refer to a function. And so it sticks that, a reference to that in there. And then log hey does the same thing. So now we have these 3 functions inside of this array. Now we come down to the for loop. And well, I'm not going to talk about that yet. Okay, so then we come down here and then we create a variable called I. We set it equal to 0. Then we say, all right, I is it less than functions.length. So functions, it goes up and finds the functions array and it says, what is your length? Length is 3. So is 1 or is 0 less than 3? Yes. So then it comes down into here. So let function at index. So it creates a variable, assigns it to functions at the array of 0. At this point in time, I is 0. So then functions at index 0, which is log high. So function at index is now the function log high. So we then call function at index like this. So essentially what you have here is you have function at index and log high that are both names that are referring to the same function inside of all of this code right here. So essentially at that point in time, if this is, a variable, and this is a variable, and this is the function, you have log high, which is, here and here that we define. If this is log high, this is referring to that function. And then down here, this function index, this variable that we created, is also referring to that function. So then when we call it right here, we say function at index and we invoke it. And so the two parentheses are what make it so we invoke a function that this is function at index. Function at index. And so that variable, we call it, and it's going to go back and it's going to call this function that's existing in memory. So this is going a little deep. We're going to go, again, we'll be devoting a lot of time to this and going a lot deeper than this even later on, but it's just kind of the general introduction to this way of thinking about memory and variables and just, some of those general principles. Okay. The array was not created before it creates. So the array is created before. So the array is not high, sep, and hey. It's the array is those functions. It's those like blocks of functions. It's kind of like one way you could think of it is it's kind of like we're saying like that. Like it's like super messy, but it's like we put the function inside of the array. So log high is not it's not a string, because right here all we're doing is just logging a string that we're defining. But yeah. So anyway, so function index is log high. We call it prints high. So now I come back up to the top. There, once we reach the end, I is incremented. So I is 1. We check to see is 1 less than 3. It is. So we come down in at function index 1 is the log sub function. So we take the log sub function and assign it to this variable. Then we call function at index, which is a reference to the log sub function. We call it, and that prints out sub. Come down to the bottom, I is incremented now to 2. So we come and check, is 2 less than 3? Yes. So you come down in, function at index 2, which is log hey. Because if you remember, arrays are 0 index. So log high is at the 0 index, log sub is at the 1 index, log hey is at the 2nd index. So we have log hey. Now we go function at index, which is log hey. We run it, and then it logs out hey to the console. We reach the end, I is incremented to 3. Come to the top, is 3 less than 3? No. So the for loop breaks. The program comes down here. There's no other code to execute. Everything finishes and returns, and it's done. So that's the general flow in an application. Those are the steps that it takes. Okay, so the array was not created before. So functions creates. Oh yeah, so I talked about that. So when it comes down to right here, so when I say const functions is this, it created an array. So it created a new array in memory. The array is full of functions that already existed. Okay, all right. If you lost on that, don't worry about it too much. Oh yeah, should it be const function? Oh yeah, sorry, Patrick, I just saw your question. Const function at index equal to functions I. Yes, that's, sorry, you talked about const. Yeah, so we're using a let because we're going to be rewriting that variable at each stage of the loop. If I did a const, then let's see. Well, actually, that didn't throw an error. I thought that was going to. Oh, because it's block scoped, so it doesn't make a difference. Okay, yeah, this is actually fine. Yeah, yeah, actually use const. That's right. So const and let are block scoped. So at each cycle of the loop, there is a new like function at index is like disappearing and then getting recreated. If you used var, then it would be like it creates the variable on the containing function scope, then it overwrites it. But yep, yes, you're right. It's actually should be const. So good catch there. But don't again, don't get confused by that if that kind of went over your head. Yeah, so we use let I because the I exists actually outside of the block. So the let I is kind of like a variable in the outer function scope. So like it's like we're defining let I right here instead of actually inside of the for loop. So this is where I is living, not in here. And that's why it has to be a let. If we change this to a const, it's not going to work. So it's because this outer scope where the I is still open, it's not changing, but in here, from a block scope perspective, it's a scope that's being created and destroyed at each iteration of the loop. So it's because const is, yeah, because the I is going to be different each time the for loop runs. Yeah, so the I loop, yeah, so the I is going to be different. And anyway, a lot of this stuff too. Well, anyway, all right. Okay. All right, so let's continue with functions, and we'll go about 10 more minutes. We've been going about 50 minutes. Usually I like to keep my lectures shorter, but, well, actually we'll revisit some of this stuff later in the day. So we'll just stop here and keep working on homework. So, all right, let me know, guys, let me know if you have any questions, and yeah, message me, or drop messages in the Slack. Feel free to tag, me or Austin or Ryan. Happy to come in and help out. Yeah, how do you use underscore? Yeah, let me just show you real quick. So it's JSBN, I can actually plug it in, but yeah, so you have to, it's tricky because you're using it in a node environment, and then you're gonna wanna use something like npm to install it. I'd actually encourage you to, well, so don't use underscore to, like, if you're doing like let's say for example like reduce, like don't use underscores reduce method to solve reduce, or don't use underscores like flatten method to solve flatten. So the point is to like recreate it. I wasn't clear about that before, but like the point is to like be recreating those functions, but to use them inside of the project, you would have to do something like there's a lot. You have to npm install a package called underscore, and then you have to require it in the file, and then you can use the different methods on the object that you require. I can walk through that maybe later. Like not today, but like at another time. So, but that's beyond the scope of what we've covered and what's expected right now. So if you're individually curious about it, I can tell you how to do it, but it requires using some different tools and things that we've not used. We will do one more lecture today. So we will do another one at, so it's almost 2 right now, 3, 4, 5. Let's do one at, we'll do another review at 5 p.m. Pacific. Yes. So for example, so like each, oh yeah, sorry, in response to Ryan's question, so just to be totally clear, I may have missed it, the point is to rewrite the functions without using the built-in higher order function. So So for example, here's each, where each is supposed to take in an array of elements, or collection, or whatever you want to call it, and a callback function. So the point is not to do like inside of it to do like elements dot cb like that. Like you can do that. That will solve it. But the point is to try to recreate it without using the built-in for each, because each and for each are like the same thing. So, I mean, a little bit like for each is tacked on to the end of an array. It's an array method, and each is just a standalone function. But so you want to try to recreate it. So the idea would be, for let I get 0, I less than elements.length, I plus plus. So there's that thing again where we're iterating over an array from left to right. And then we're going to say CV is going to get elements I and then I like that. So essentially what a for each is doing is it's simplifying doing this, because this task of writing a for loop to go over an array from left to right, you're using that all the time. Like that's such like a super common task. And so the idea is to just make it so now we can use an each function, and it simplifies the behavior. Yep. Yeah. But within reduce or map or whatever, you can use each. Don't use like for each inside of the each function, or don't use map inside of the map function, like array.map or array.reduce inside of the reduce function. But if inside of reduce, if you wanted to use a for each, that's fine. That's totally fine. Or you could reuse your functions that you've made. That's totally fine. Just don't use the built-in array ones to solve the thing that you're trying to recreate. Just because that kind of cuts the corner. But yeah, anyway, you can do it the other way. Great questions. All right, thanks everyone. Talk to you later.